relatively painless, not too bad. Guess what we get to do next? It's Friday, right? Yeah. Fraction Friday. Oh yeah. Whoa. Fraction Friday. We're going to talk about fractions. Just an introduction right now. But you need to know that fractions are going to be with you your however many math classes you take. You're going to get fractions all the time. So let's do this. Let's talk about section 4.1. We're in chapter 4 now. We're going to talk about fractions. Fractions happen, man. We get lots of fractions in math. In fact, most of our problems end in fractions somehow. Actually, every one of our problems ends in fractions. We can always make a whole number into a fraction. We're going to learn that later. So we are always, literally always dealing with fractions in some form or another. The way fractions look, if you've never seen a fraction before, which isn't true because you've been in this class, we've actually seen fractions before. Fractions look like things like that. Like 1/2 or 3/8. Or 7/4. All of those are fine fractions for us. There are a couple things about fractions we need to know. Let's look specifically at the 3/8. Fractions have a different name for the top of a fraction and the bottom of a fraction. Up till this point, I've been saying the top or the bottom of a fraction. That's really not appropriate. Because we have these certain names that is more specific than the top of a fraction or the bottom of a fraction. The top of a fraction, up here, in this case our 3, it's called the numerator of our fraction. Can y'all say numerator for me? Numerator. Good. Thanks for the enthusiasm. Numerator. Do you know what the bottom is called? Denominator. The denominator. Your little cross U. Yeah, it's kind of fun to say. I love that word. Denominator. And this right here, that's our fraction bar, signifying that we in fact have a fraction or division, which is what a fraction is all about. There really are two types of fractions for us. We have certain things called proper fractions. And we have other things called improper fractions. It's kind of a misnomer, though. There's really nothing wrong with an improper fraction. We deal with these things all the time. What makes something proper and what's improper? Maybe you know this already. Which one of these is a proper fraction? Is this a proper fraction?
Yes.
This one?
Yes.
This one?
No.
Okay, so proper fraction means when the numerator is less than the denominator. Numerator less than denominator. That's when you have a proper fraction. The other one, bless you. The other one is considered an improper fraction, such as 7/4. Or this one's not on the board, but I'm going to write up here anyway. Something like 5/5. 5/5. That would be considered an improper fraction. There's nothing wrong with it. We write these all the time, but it's just called an improper fraction. It happens when the numerator is greater than or equal to the denominator. Now, what's kind of nice about our fractions is they're always represented pictorially if we want them to be, which means we can get a really clear picture of them just by drawing it and kind of understand what these fractions are all about. We're going to practice that right now, drawing some pictures of these fractions. Well, let's look at 3/8. Again, 3/8 is proper or improper? Proper. What's the numerator?
3.
Denominator?
8.
Good. We can represent this as a picture. The idea is this. The fraction tells you two things. The first thing it tells you by looking at the denominator of our fraction as to how many parts each whole is split up into. So when we look at this fraction, we know that whatever we draw, like our circle here, we're going to cut that into 8 equal parts. That's what the fraction says. Bottom part, our denominator says, you're going to cut this into 8 equal parts. Bless you. Bless you again. That's horrible. I got to redraw that. That's ridiculous.
That's what I did.
Ah, that's much better. So the bottom of our fraction, the denominator tells us how many parts we're breaking up a whole into. The top part tells you how many we're actually selecting out of those parts. So how many are we selecting here?
3.
So we broke that into 8 parts because our denominator said 8. And we're selecting 3 of them. So we can represent that by shading 3 of them. Now it doesn't have to be 3 in an order. It could be 1 there, 1 there, 1 there. As long as you just have 3 out of those 8 parts, that represents 3/8 of the whole.
Like a pizza
Could be.
or a cake.
Good, Jeff.
Or a pumpkin pie.
Have you bunch of pumpkin yet? They're expensive. How about 4/4? What's 4/4 mean? Why? Yeah, well this says break it into 4 parts. Sure, no problem. Then shade all 4 of them. If you've broken something into 4 parts and shaded all 4 of them, you've just shaded the whole thing, which is how we get the fact that 4/4 or 5/5 or anything over itself equals 1 whole. Last one, let's try. Let's do 7/3. 7/3. Ladies and gentlemen, how many parts do I break up the whole into in this case?
3.
Even though the 7's up here, this still says you're breaking each whole part, each whole circle or square, whatever you draw, into 3 parts. And we're supposed to take 7 of these. Now, do I have enough to cover 7 shaded pieces with this one? That means I need to draw another one. And I'm going to keep drawing them with 3 pieces each until I have enough to cover it. So I have 3 here. I need to draw another one with, is it 3 or 4 now?
3.
Still 3. The denominator didn't change, did it?
No.
So 3 here. Do I have enough to cover it yet? I have 1, 2, 3, 4, 5, 6. How many more do I need?
1 more.
Two or 3.
I never ever change the number of parts I'm cutting it into, ever. So if I have a denominator of 3, that means 3 parts here, 3 parts here, 3 parts there. That's what the denominator means. You're cutting every whole into 3 parts. Now you go ahead and shade the number of parts that this says. So we're going to shade 7 parts. 7 parts means I have all of these 3, all of these 3. That makes 6 so far. How many am I going to shade over there?
1.
That represents 7/3.
So if you reduce it, it's going to be 2 1/3.
This is reduced. Now, if you mean right as a mixed number fraction, we'll get to that later. This is reduced. Okay? A lot of people make the mistake of saying, oh, can't you reduce this? No, you can't. You can't reduce it. We haven't even talked about that yet. But reducing means having common factors on the numerator and denominator. You do not have that here. We're going to be very clear on using the appropriate terms in the class. So when you're talking about reducing, you mean taking a fraction and simplifying it by common factors. When you mean writing as a mixed number, that might be what you're thinking of if you're thinking 2 1/3 right here. There's a difference, and we'll get to both those later on. Okay, so we got these things called proper fraction, improper fractions, a numerator, a denominator, and drawing some pictures. Do you feel okay with our fractions so far?
Yes.
All right. Let's keep going. Quick little review here. How much is 6/6, please?
1.
Good. How much is 7/1?
7.
Which is how, as a matter of fact, you can change a 1 into a fraction. You can make it anything you want as long as it's over itself. And you can change a whole number into a fraction by putting it over 1. That's always possible for you. Anytime you have a whole number, put it over 1, then it becomes a fraction. So literally, you have dealt with fractions every day that you've ever dealt with a number. It's automatically a fraction. 0 over 6, ladies and gentlemen. How much is that?
Under. Oh, that's
Okay. One of them's good and one of them's bad. Which one is which one is good and which one is bad?
0 over 6. 7 over 0.
Good?
Yeah.
Good. What does this equal?
0.
Yeah, don't give me 6 or anything crazy. That equals 0. And this one equals?
Undefined.
It does not equal 0. It's undefined. But I liked the enthusiasm. Awesome.
She was ready for that one.
Ready. Ready. Okay. Let's do a few more graphs to get the hang of this. I really want you to get some pictures up here. I'll have you do some on your own. Then we'll talk about how to convert between mixed numbers and improper fractions. That'll end our day. So let's do some graphing. First thing I want to graph, I'll do these with you. They'll go pretty quick. I want to do 5/7. 5/7. How many parts am I going to cut my hole into? 5 or 7?
7.
And how many am I going to shape?
5.
When we're doing our fractions, of course the denominators tell us how many parts to cut our hole into. So here we're cutting into 7 parts, and we just have to shade 5 of them. It really doesn't matter which 5 you shade, as long as you get 5 out of the 7 shaded. Next one, and you can draw rectangles, you can draw circles, squares, whatever you really want to do. I'll draw a circle for this one. This says we cut this into 3 parts, and of course we're going to be shading 2 of them. How many parts do we cut the next one into?
6.
And we'll shade how many?
4.
Now this one was designed to get you to see something.
Same thing?
Yeah, it is the same thing. If we have 2/3 and we have 4/6, you see how ultimately we've shaded the same amount of area here. If you had a pizza that was sliced into 3 pieces and a pizza that was sliced into 6 pieces, and you took 2 of the first pizza and 4 of the second pizza, you'd have exactly the same amount of pizza. And we're going to learn about simplifying fractions from one to the other in a little while, probably next time. Okay, moving on. How many holes do I need for this example?
2.
Good. The first one doesn't have enough to cover it, so I do have 1, 2 holes, but do I still cut this one into 6 pieces?
Yes.
Okay, that's good. Yeah, I got to shade all 6 of these. And how many of those?
1.
That gives me my
7.
7/6. Couple more.
3.
There's 3. There's 6. We have to have enough to cover all 8 shadings here. So every hole we have is 1, 2. We have 3 holes that are cut into 3 pieces each, and we're going to shade 8 of these pieces. So that's all of these. That's all of these, and that's all but 1. Yeah, 2 of those. How about the 5/4? How many pieces do we cut that into?
2.
Hopefully 4. 4 pieces there. 2 holes though, yeah, you're right. 4 pieces there. We're going to shade 5 out of those pieces. We shade all 4 of these. We had to have 1 more hole to cover this last piece that we weren't able to get to with this 4. So we have 4 out of 4 here, and we have 1 out of 4 there. That's giving us our 5 out of 4. In fact, if you were to draw pictures, you can actually add fractions this way. And lastly, we have something with 7 pieces. Shading all of it, that's right. All 7 out of 7, we shade the entire thing. 7 out of 7 is 1. How many people had a pretty good idea about these pictures, these fractions? Do you feel okay with your introduction to fractions? Next time we're going to start talking about mixed numbers, improper fractions, and then we'll get on to simplification. That'll be on Monday. So what are these things, mixed numbers, and what are these things compared to improper fractions? We're going to draw one more picture of a fraction, which we kind of did this last time, but it will lead us into how to find out the similarities between these things. So let's look at a mixed number. When I say a mixed number, or a mixed number fraction, what we mean is some value that's greater than 1. It's definitely greater than 1. And it also has a whole number and a fraction part. Let me give you an example here about what I'm talking about. Do I have more than one?
Yes.
How many holes do I have, as a matter of fact?
2.
2. Do I have anything more than 2?
Yeah, I won't have to.
Sure, how do we find out 1/2? What tells you 1/2 up here? Okay, so it's cut into 2 pieces. That means our denominator is 2, and only one of them is shaded. That's how we're getting the 1/2. Are you all okay on getting that this is 2.5? 2 holes and 1/2. Great, okay. So that's 2.5. That's a mixed number. It's more than 1, definitely more than 1. It's got a whole number part, that's our 2, and it also has our fraction part, that's our 1/2. However, could you also represent this as an improper fraction?
Yes.
Yeah.
Okay, remember improper fractions, the numerator was larger than the denominator, but the denominator still stood for how many parts each whole is cut into. How many parts are these cut into?
Yeah.
So this is going to be something over 2, do you agree?
Yeah.
Why 5?
Because 2 times 2.
Okay, so we don't do this, right? We don't go, oh, there's 1, 2, 3 pieces shaded. What we're doing is counting each little part that's shaded. So 1, 2, 3, 4, there's 5 pieces that's shaded. And each one is cut into 2 pieces. 2, 2, 2. That's where we're getting the denominator of 2. Are you okay that this is going to be 5 halves?
Yeah.
Well, here's what we did. We took the same picture and we found out 2 different ways to identify that. This was 2.5, but this is also 5 halves, right? So what that means to me is that 5 halves and 2.5 represent exactly the same thing. So here we know that 5 halves equals 2.5. Is there a way mathematically that we can get from one to the other? Sure. Yeah, in fact, if we look at that, we know that 5 halves means 5 divided by 2, right? Well, let's set that up. Let's do 5 divided by 2. If I set up my division symbol, can you tell me what number should go on the inside of my division symbol?
5.
Good, the number on the top. Not necessarily because it's bigger, but because that's on the top. That's on our numerator. 5, okay, cool. And on the outside, we're going to put our 2. Can you tell me how many times 2 goes into 5?
2.
We multiply, we get our 4, we subtract, we get our 1. Now here's what we do with that 1. Now that we're in fraction world, right? We were in just regular old remainder world over there in our first couple chapters. Right now we're past that. We're now into fractions. Here's how you represent that 1. 2, that stands for your whole number. We've got 2 times that 2 goes into 5 without going over. This remainder of 1, here's how you represent that from now on. We're going to take that 1 And we're going to say that we couldn't really make up another whole out of that. We couldn't divide another 2 into that, but we still know that that 1 is being divided by 2. So we take that remainder, we put it on top of whatever you divided by. And that's the way we can change an improper fraction into a mixed number.
Or you put the decimal point behind the 2, bring it down.
We're not to decimals right now, we're dealing just with fractions. Good. Just with fractions right now. Let's try a few more together. So we're going to try to change 7/3 into a mixed number. What number goes on the inside of our division sign, please?
7.
Cool, and 3 goes on the outside. How many times does 3 go into 7 without going
2.
over? So when we multiply, we'll get 6. When we subtract, we get 1. And what is the fraction part of my mixed number here?
2.
Wait, no, I have 2 already. What's the...
1/3.
1/3.
So I'm going to take this 1 as my remainder, put it there, over whatever I just divided by 3. So what this tells me is that 7/3 is the same thing as 2 and 1/3. We can go from our improper fraction to a mixed number. We'll try a couple more together. We'll go talk about going backwards, and then I'll have you do some on your own. Let's try 15/4. 15/4. So on the inside of our division symbol, we'll put our 15, and we're dividing by 4. So the fraction tells us what to put where. Our numerator goes on the inside of our division symbol. Our denominator goes on the outside as our divisor. So we're dividing inwards, taking 4 into 15 how many times?
3.
Good. We do the same process. We're going to have 3. We'll still multiply, get our 12. We'll still subtract. How much will we get?
3/4.
3y over 4.
That's the number you're trying for.
That's what we check for. So whatever we're dividing by, that's going to be our denominator no matter what. So our denominator is 4 here. It's a way to check your answer. You should get, well, the whole number goes for sure, and our remainder goes here for sure. Our denominator will not change. So if it's over 4 here, it will be over 4 there. That won't change. So 3 3/4, that's it. So 11/3. On the inside, we'll put our 11. On the outside, we'll put our 3. How many times does 3 go into 11 without going over?
9.
3.
I mean 3.
Yeah. Gives you 9, though. We subtract, we get our 2. We can't go any further since we have our 2 that's less than 3. We're going to make that our remainder. We put that as our numerator. We put it over 3, and we're done. How many people feel okay about changing those things? Now, the question is, can you go backwards?
Yeah.
Go backwards. So 4 and 5/6. Can we change that, a mixed number, where the whole number is 4 and the fraction part is 5/6, can we change that into an improper fraction?
Yes.
It is. Well, you know what? We're going to go exactly the opposite of what we just did. Over here, we divided, then we subtracted. We're going to go in complete reverse order. We're going to
Multiply and add.
multiply and add. Yeah, so if we divided and subtracted, we're now going to multiply and add. But what do we multiply by?
6 and
4
4.
by the
Denominator.
And then add 5.
Cool. That's exactly right. So we're going to multiply these two things, and then you're going to add these two. So we'll do our 4 times our 6. We take our denominator times our whole number. In this case, we're going to get how much?
24.
29.
29 plus 5.
24, yes, and then we add the 5, so we get the 29.
Over 6.
Yeah, I told you the denominator doesn't change, right? So if we have a denominator of 6 here, we're going to end with the denominator of 6 here. Can you always check your work?
Yes.
Yeah, as a matter of fact, here, if you did 3 times 3, that's 9, plus 2 is 11, we'd get 11/3. You can always go back and forth and check your work. That's kind of nice. You can always make sure you have this right. Okay, at this point, I'm going to give you something to do on your own. If I give you a mixed number, I want you to change it to improper. If I give you an improper, I want you to change it to a mixed number.
improper?
15 over 4 is considered improper, yes.
Improper?
Improper. Doesn't mean it's wrong. We still write fractions like that all the time. It's just the name that we give
3
it.
and 3/4 would be considered proper.
No, 3 3/4 would be considered a mixed number. So go ahead and change these things. If it's a mixed number, make it improper. If it's improper, make it a mixed number. By the way, before you get to your homework, I'd like you to read this section, 4.1. I've given you most of the problems that you'll be getting, but you do need to read that section. There's some things that I have not gone over. There's some, I believe, some graphs in there, some other things that are very pertinent to this class that you will need to read. So make sure you do that.
Read what, the
4.1. Right. Just the section before you start your homework, okay? Just make sure you look that over. Okay, let's get started on this thing. So first one, on the first example, I've given you already a mixed number. What I'm asking you for is to take that and change it back into an improper. We're going to have to do this in our class a lot, change things back into improper to work with them. What do I need to do to change 12 and 5/8 into an improper fraction, ladies and gentlemen?
multiply over
So 12 times 8, 96. And then from the 96, what do we do?
add 5.
And how much are we going to get?
101.
Yeah, 101 over 8. You could check your work, right, by dividing that and then subtracting. That would work. Now, the next one, I've given you an improper fraction. So 14 over 5, that's improper. We're going to change that into a mixed number by dividing. So 5 goes into 14 2 times. We'll get 10. Subtract, we get 4. So we're going to have 5 and 2/4. How many people got both those right? Good, 5 and 2/4. Now, we haven't talked about simplifying, but we're going to do that in the next section, maybe in about 5 minutes. We'll start talking about simplifying. We'll be able to make this a little bit simpler.
Wait a minute.
Is that right?
No. No, it's 2 and
Just
4.
making sure. Geez, my goodness. What did I do wrong? It's a common mistake that people make all the time. 4 bits.
2.
Just checking to make sure you guys are still awake. I see kind of some zoned out eyes out there. Just checking, just checking.
Yeah.
You guys passed. Congratulations. Okay. Yeah, it's definitely 2 and 4/5. We take our whole number first, and then we write our fraction part after that. Next one, do we have a mixed number, or is this improper? Which is this?
Improper.
That's improper.
Very good. So when we divide, we'll have 26 divided by 3. 3 goes into 26 how many times up?
8 times.
Subtract, and we get,
2.
so we'll have what?
8 and 2/3.
8 and 2/3. Last two, we're going from, what are these known as?
Mixed
Mixed
numbers.
numbers.
We're changing those into impropers. So we're going to multiply, we'll get 63. We'll add 4, we'll get,
67.
the denominator does not change. Doesn't change. Next up, we'll do our 5 times 8, that's 40. We'll add 1, we'll get 41 over 8. We're good to go. How many people feel okay with changing improper to mixed number and mixed number to improper? Good. That ends our section 4.1.